so I'll probably do that tomorrow morning. So changing a motor, 3-phase motor from star to delta. I'm sure most people know how to do this, and there's a diagram usually under the front cover which explains how to do it anyway. That's in star and that's in delta, which is straight across. Some people look at this and they'll wonder sometimes, how on earth can it get to both phases? It's quite simple really, because what you've got is U1 doesn't go to U1 there, so that's U winding, the U winding, V winding, W winding. U1 goes out to the motor through the winding and comes back there, U2. So the what U winding is between that terminal and that terminal. The V winding is between that terminal and that terminal. The W winding is between that terminal and this one across here. So if you put a phase on there, a phase on there and a phase on there, you've got your in between phases. That's how it works. If they were all in line, it wouldn't work, would it? So we'll put the little bars back on. Raining outside again. 10:10 at night. Supposed to have been packing in about half an hour ago. I thought I'll just get the motor ready. These are handy. I had these from my old electrical days, nut spinners, really handy. It saves you sticking a spanner on and chancing yourself at stripping the thread. You're only doing this by hand. Which is quite good enough, quite tight enough. I'll put the washers and bolts back on there so I don't lose them for tomorrow, for when I connect the motor up. So that's it, all ready for tomorrow. One motor. That's its ratings. So a 230 volt delta, 50 Hz, 1410 RPM, 0.75 kilowatt, which is 1 horsepower, 3.1 amps, and giving a cosine of 0.76 power factor. If you put it in star, 400 volt star, it'd still be 1410, it'd still be 0.75 kilowatt, still a 1 horsepower motor. It'd take much less current, look, as you can see, 1.79 amps with a 0.76 cosine. if you run it on different voltages. I suppose these voltages are for abroad, they're not for this country, at the 60 Hz too. And it's ironically 1690 at those voltages and frequency, which is important. I'm glad I've shown you this. This is important because if you put your inverter on and you accidentally set it for 60, and by the way, a lot of these Chinese imported inverters and a lot of others, when they come, they've been set at 60 Hz. It's important that you change it to 50. That is very important. It's one of the first parameters you set, the frequency of the motor. And some people get this mixed up with the frequency of what they want the drive to run at, which is a totally different story, totally different thing, the issue. This is the first original parameter, is you tell it what the voltage is of the motor, you tell it the frequency, 50 Hz. If you tell it it's 60 Hz, you get all sorts of stupid things happening. I've done it. I've done it in my past. I'm an ex-electrician. I've fitted hundreds, if not thousands, of inverters. But in the setup procedures, some of them did come 60 Hz, and I left them like that with all sorts of tripping functions happening, and it was my fault. So always make sure you set that at 50. Further on in your settings, you've got a minimum frequency setting, and you've got a maximum, which is something you can set and use a potentiometer for, as I'm sure most of you know. And then you can vary your speed from, you know, pretty much stood still up to its full, and then you can overdrive it, take it up to 70 Hz if you want, and that'll give you, you know, a fair old speed, probably over 2000 RPM. You can go. This motor is available in a 2-pole, 4-pole, and I believe 6-pole. This is a 4-pole motor. There's much more torque in a 4-pole motor than what there is in a 2-pole motor. However, a 2-pole motor runs at double the RPM of a 4-pole motor. So if this motor was a 2-pole, it would run at 2800 RPM. I could have got one of those, but I didn't, because at real low revs, they've got no torque at all. You need the 4-pole one. So again, you know, that's another issue, that when you're buying a motor, if you're going to use it for a drill, milling machine, a lathe, you really want a 4-pole motor. I wouldn't go for a 2-pole, not unless you're looking at a CNC machine where you're running at ridiculously high revs. You know, I mean, some of them CNCs run up at 10,000 RPM. You probably would want a 2-pole motor then, but that's, you know, different. I'm talking about normal milling machines. Hope that helped anybody thinking about either modifying or changing the motor because of issues, bearing problems, burning out. And I mean, some guys have got these in DC drives and they don't wish them to be DC anymore, and they want to fit an AC motor with a VFD or an inverter drive. That's what I call them. There you go, easy enough to do. Right, I'll post another bit to this once I've got this fitted back on. We'll see if it works. Okay, I'm not going to turn this on because there's no motor there, obviously. But just going to show the inverter for those that either don't know what an inverter is or they haven't seen one. This is basically an enclosure. It came like this. I've got my one up there. I don't have it in an enclosure. I've had a lot of stick off people, but it's fine. You don't need them in inverter. There's no need to go, but most people decide to put a nice enclosure, which for this one it's particularly handy, because if you have a look, it's been quite well made. I didn't do it. This is somebody else's handiwork. Although the guy I bought this Tom Senior off, he was an electrician as well, a maintenance electrician in a large steelworks down Sheffield way, which is probably where he got this inverter from. So this is a Toshiba, good quality. This thing's got millions of parameters in there, and as you can probably see, 1 phase, 200 volt, 0.75 horsepower. Ignore the 200 volt bit. It's this one's on 220, don't like 230. But yeah, so you can run it and stop it and do everything from the little keyboard on there. But then once you've wired it all up properly, you'd make a remote station, and you would do some parameters in here. You'd alter, instead of your speed being there and your start stop, you'd alter the parameters to tell it had a keypad exterior to it, which is that basically. So forward, off, reverse, and your speed. And this is from a power Traverse X drive, but that is the inverter, and then a speed showing there, which is just a cheap imported thing driven by this little sensor, which is just in there. You can see it on a magnet in there. So that's your inverter. And this is a 24-volt power supply. As I say, two little relays for forward and reverse, and a breaker for the control circuit. It's made a nice job. The wiring's not the perfectest, it's not the neatest, but it doesn't matter. It's fine. All well connected and works fine. As I say, the only reason I changed this is because I was struggling with the low speed, low frequency, no torque on the motor. In fairness, I've since found out that when this machine was new, it was single phase, it wasn't 3-phase. So when this was new, it was single phase, and it was 3/4 horsepower. The motor that I've taken off is 3-phase, and it's only a 1/2 horsepower. So in actual fact, it was a lower horsepower rating than the what should have been on this machine to start with. So somebody's down-rated it. I knew somebody had done work on it, because when I was working on this motor, I could tell with the hammer marks and everything on here that somebody had had this pulley off, and they'd had this off, and they'd altered it a little bit. So I knew it wasn't original. So I've gone up to a 1 horsepower motor. You can't beat horsepower. If the inverter will drive it, then why not? I might not ever need the 1 horsepower of it, but what was the point of just going back to a 3/4 when the inverter would drive a 1 horsepower?